Assalamualaikum and good day to everybody. In this video, we're going to talk about pass by reference, which is another way to pass your variable from a function call to the function definition. So we know that a variable has both value and a unique address. So far, what we have learned is that we pass the value of the variable, and we call this pass by value. Another way is that we can pass the address of the variable, and we call this pass by reference. When we do pass by value, the receiving function or the function definition does not have access to the actual arguments in the function call. In other words, it cannot really change the value of the actual variables. This is an example of a program that uses pass by value. So we have a function named find here. If we look at the function definition, function find would change the value of its formal parameter x. So let's go through the program. First, we declare an integer variable and we initialize the value as 5. So in the memory, we have variable a with value 5, and then the next statement we output the value of a. The output is before a is 5, and then we call function find and we pass argument a to function find. So since this is passed by value, so we pass the value of a to the formal parameter in function find, which is x. So now x has the value of 5, and then in the function definition we add 3 to variable x. So x is no longer 5, it's 8 now, and we return back to the point of call and we do another cout statement to display the value of a. So after a is, it's not 8, but it's still 5, because what we change just now is a copy of variable a. It's not the actual variable a that we change. Function find doesn't have any access to the actual argument a. Whatever changes that we've done in function find to change the formal parameter, it's not gonna affecting the actual arguments. So that's why we call this as pass by value. Even the formal parameter of function find is using the same name as the actual argument, which is a. It's not going to change anything. The a in function find is still just a copy of the a in the function call in the main function. So this is still passed by value. So how do we make the changes in function definition to affect the actual arguments in the function call? One way is that we can return back the value of x in the function definition. So if we look at function find now, it is no longer a void function, but it returns something. It returns an integer value. So the data type, the return data type is not void, but the return data type is int. So if we look at the function call now, a equals to find a. Whatever returned by function find is assigned to the variable a. And then if we look at the second cout statement, after a is 8, which is the value that we have changed in the function definition. This is still passed by value, but the difference is that we return back the value of the variable that we have changed to the calling function. So like I said earlier, we can pass the variable address instead of the variable's value, and we call this pass by reference. So what happens is that if we do this, the function definition now has access to the actual arguments for the pass variable. You only use pass by reference when you want to change the value of the actual arguments. Otherwise, you don't need pass by reference. You only need to use pass by value. So it's quite simple really to do pass by reference. You just need to add an ampersand operator, okay, or we call this as address of operator before the name of our formal parameter in the function definition. This is the same program as before, but now we're using pass by reference. You know the program used pass by reference because when you look at the function prototype and also the function header of our function definition, the formal parameter now has ampersand operator after the data type and before the name of the variable. So here we have int ampersand x. The same goes for the function prototype, int ampersand x. What happens is that when you do a function call, find a, x is not a copy of a. It's not another variable, but x is an alias for a. It also pointing to the same memory location as a. So when we change the value of x, x equals to x plus 3, so x is 8 now. Value of a is also changed as well. So the output now is before a is 5, after a is 8. So let's use a trace table to see how the program works. First, we declare a variable a with value 5. So we have variable a with value 5 in the memory. And then we do an output statement before a is 5, which is the value of variable a, and then we do a function call. When we do a function call, we go to the function definition. The program creates what we call as reference variable. In here, the name is x. X is an alias to a, or in programming we call x is pointing to a memory's location. And in the function body, we add 3 to x. X equals to x plus 3, so now x is 8, and then we return to the main function. So when we return back to the main function, all local variables are destroyed. So x is no longer in the memory. You cannot refer to x in the main function. And then we do another cout statement after a is a. So the value of a is now 8 because we have changed that value when we execute the function find just now. And then return 0, we terminate the program. So we can see that just by adding ampersand in front of the formal parameter, now the function definition has access to the actual arguments, because now we are using pass by reference instead of pass by value. In ampersand x just now is what we call as reference variables. So using reference variable allows you to work on the actual argument instead of a copy of that argument. So now you can modify the value of the actual arguments. So this actually provides a way for a function to return back more than one value as a result using pass by reference.